Okay, what we're looking at is a Hewlett-Packard 5382a. It's a 225 megahertz frequency counter. Has a three-step attenuator, times 1, 10, and 100. Has a gate time of 0.1 second, 1 and 10 seconds. So the 0.1 is for the megahertz and the 10 seconds will read hertz, give you the most resolution. It's in very good shape. As you can see from the front panel, it hasn't got any of the characteristic yellowing that happens so often with these particular units. The case is in good shape. Has a couple of minor scratches, like there's one on the side there. The top looks very good. A bit of dust on it, but looks great. No scratches to speak of there, and nothing on the side. Very nice shape. We right now are feeding a signal in from this PTS frequency synthesizer. This will synthesize frequencies with crystal accuracy to like within a quarter of a hertz. And right now we are feeding it. The PTS, by the way, works from a range of 100 kilohertz up to 160 megahertz. So we're going to use it to test up to 160 megahertz, and then we're going to switch to this Farnell, which could go all the way up to 520, but it'll take us up to 225 maximum at that point. And we'll have 4-place accuracy past the decimal point with it. Okay, we're at 100,000 hertz, and we're going to step it up here. We're going to go to 200 and work our way up to 160 megahertz on the PTS here. There's 200, 300, 400, 500, 600, 700, 800, 900, 1 million, 2 million, 3 million, 4 million, 5 million, 6, 7, 8, 9, 10 million, 20 million, 30 million, 40 million, 50 million, 60 megahertz, 70 megahertz, 80, 90. At this point, I'm going to have to change to the megahertz position because we've just not got enough digits to display it. So we're going to go to 100. All right, we're at 100 megahertz. And I'm going to take us up to 160. So here's 110, 20, 30, 40, 50. Okay, we've switched to the Farnell generator. We are at 150 megahertz. The Farnell takes a little longer to settle down, but she'll give you 4 decimal place accuracy. The last place is the 4th place is the flakiest place, and anything beyond that, it's not controlled. but we'll be able to take this from 150 up to 225 and see how we do. So, all right, let's go ahead and hit 160. Give it a moment to lock in on the frequency. It's got a phase lock loop in it. All right, looks like we hit it. 159, 160.0000. Looking good. 170. Alright, I think we hit it now. There's your 170. 180. Goes through a little overshoot and undershoot, and it latches in. We're at 180, 4 decimal places. 190. You'll see it overshoot, probably goes to 191, yep, and then she'll swing under to 189, and then she'll center out at 190. Okay, we're at 200. Alright, 210. There we go. 220. And we go up 1 megahertz at a time till we hit 225. There's 220. 221. You know, I'm going to just take it to 5 and let's let it settle out. Save ourselves those steps. There we go. 225 megahertz to 4 decimal places. Alright, I've connected myself up to an oscilloscope calibration device I have, so I can provide some crystal controlled low frequencies. In this case, I'm providing a 20 Hertz signal. We are in the kilohertz mode, so we are reading 0.02, in this case 1. So we're reading 21 Hertz right now. We should be reading 20. There's a 20. I could switch to its 10-second average, and we would give ourselves a little more resolution here. We'd be reading in whole hertz, but you got to wait 10 seconds for the signal. So here we got 20 Hertz. This should be 50. Again, we're on this 10-second average, so we got to wind up waiting 20 seconds for a good reading. But there's 50.1. There's 50. This should be 100. We'll get it on this period. Okay. We'll wait one more count. Okay, it looks to me like 100.1 is it. Okay, we're going to go to 200. Okay, we're going to go to 2 milliseconds would be 500. One more count period here. If you catch it in the middle of a count, you're only going to get a partial. Okay, there we go, 500. Let's just wait one more go around, see if she settles out. Okay, the next position would be 1,000. We got up to 886. Give it one more counts and it'll give us a better average. There you go, 1,000. Alright, this should be 2,000. There we go. Okay, and this should be 5,000. And then we have 10,000. And then the next step would be 20,000. Give it one more hit here. There we go. And then our last step will be 50. There you go. So my scope calibrator doesn't have anything between 50 and 100, but we know from 100 up it was fine, and we know from 50 down it was fine. You can assume that in between is perfect. Gentlemen, we have a very, very nice counter here. Useful for anything you're doing in audio all the way up to 225 megahertz. Covers one heck of a lot of range. So it's like I said, it's a nice shape. We have a manual to go with it. And very nice manual. And in this manual we have operational techniques, specifications, we have circuitry, schematic diagrams, the whole shot. So you'll have the manual, you'll have the counter, and not sure what you're going to need in terms of a test lead, so what I'll do is I'll give you a BNC to a set of gator clips. That's like the ultimate as far as what you can connect it to. If you can go BNC to BNC, I'd advise you that's the best way to make sure that you're getting a good signal. But I want you to get the most use out of it, so we'll provide you a BNC to a set of gator clips. So there you go. Happy bidding and good luck. Thank you for listening.